This lesson is on the mean value theorem for integrals and average value. And most of the time we're going to use the average value concept, but I'm going to go over what that mean value theorem for integrals says. It says the integral from a to b of f of x dx is equal to f of c times b minus a. Now, what is this and what are they getting at? So, first of all, again, what does it mean to be integral from a to b of f of x? That means that we have some graph that we are looking at called f of x, and we are considering that graph from point A to point B on the x-axis. And because it's the integral, we're looking at this area. Struggling here. This area in here. Okay. Now, this over here is actually the height and base of a rectangle. And so what this is saying is that somewhere between A and B there's a C. So C is an x value somewhere between A and B. And if we choose that right place, then, and I'll just guess like right here. It's not always necessarily right in the middle. That y value of that point would be f of c. That's where that's going to come from. But anyway, if I choose that correct point, I can make a rectangle over that section that has the same exact area. And I've chosen a pretty bad C. Let me try again. Okay, maybe, let's say right here. If I choose that point with a y value here, I make a rectangle using that as my height. This does look like a little bit better of an option. Then the area of that rectangle would be the same exact area as what we have under the curve from A to B. So looking at my rectangle, I have a little bit of a gap here on the outside, but then I'm assuming that this little amount here would fill that in. This area of the green rectangle would hopefully be the same as the blue. But that's what they're saying, that there is a point that you can find where that area of a big rectangle is the same as the area of found underneath the graph. Now, how did they get this f of c b minus a? Well, that's just how you get your rectangle. The b minus a is what gives you this distance here. Like if b was 8 and a was 2, you would subtract and say, okay, that distance is 6. So that's just like the base of the rectangle. And then the f of c is the height of the rectangle. So they're saying the area under the curve is the same as the area at this rectangle if you choose the right C. Okay, so let's find C in a real problem. And so this time our function is x squared, and we're on an interval from 0 to 2. So that's our A and our B, and we want to find the C. So I'm going to take my integral from 0 to 2 and put my function. So this is talking about that exact area. And then over here I'm going to have f of c times b minus a, so 2 minus 0. Now, what is f of c? F of c is what you get when you plug c into your function. So really that is c squared. So I'm going to write that as c squared. Okay, on that side, 2 minus 0 is 2, and then you have 2 times c squared, so that simplifies pretty easily. Over here, you're doing the fundamental theorem of calculus. So you take your antiderivative, and you're going to evaluate it from 0 to 2. So if I plug in 2, and then I plug in 0 and subtract, I'm going to set that equal to the 2c squared. Well, 2 cubed is 8, times 1/3 is 8/3. 0 times anything and 2 any power is 0, so this whole side just becomes 8/3. And this side is still 2c squared. And so now I just have an equation to solve. I'm going to divide by 2, which makes that 4/3. And then I'm going to take the square root. So if I square root both sides, again, I want to think about square rooting the top and square rooting the bottom. Well, the square root of 4 is 2. Square root of the bottom, the 3, we are not sure about. You can actually leave it like this for the AP exam. You could probably even leave it as this, so either one of these will work because those are exact answers. You don't have to rationalize your square roots. Okay, so what does that mean? That means when C is this particular x value, which if you want to know exactly what it is, type it in, see what that decimal is. It should fall between the 0 and the 2. Again, that is the place where if you pick its height, that rectangle will have that same area. So that has found C for us. Okay, now I want you to just think about something for a minute. If we solved that mean value theorem formula for f of c, so I want to get this by itself, all I would really need to do is divide by b minus a, and I would have that f of c by itself. And on this side, I would be dividing this integral from a to b by b minus a. This is going to be something special, and they're not going to write it exactly like this, so let me show you how they will. Okay, so they've written this as 1 over b minus a times that integral instead of sticking the b minus a under it. But this right here has a special name. This is called average value. And so you will be asked to find the average value in certain problems. And this actually comes up more often than your mean value theorem for integrals. This is a useful formula, and you'll see it in free response questions and multiple choice questions. Now, that means that we now have 2 averages to keep straight. These are the only 2 averages that we will be dealing with. And so here is how we remember the difference. Average rate of change is what we dealt with before. That is your slope formula, and your units go one step down. And what I mean by step down and step up is like the order of original derivative, second derivative. So your original, your derivative, your second derivative. So for average rate of change, if they ask us for an average rate of change and we were dealing in units that were meters, the new units would be in meters per second. The answer units would be in meters per second because your units would go one step down, like in the derivative direction. Average value, what we're talking about today, is this formula, not the slope formula, but it's this formula. And the units will actually stay the same as what you're given. So if you're given meters, your answer will be in meters. If you're given meters per second, your answer will be given, or your answer will also be meters per second. So when you read a word problem and they are asking you something that has the same units as what you're given, and they're asking you for an average, this is the one they're talking about. You really have to pay attention to the units to be able to use the correct formula. But it's one of those 2. You just have to decipher which one. Okay, so we'll do an example of the average value. So here I have a function, and I have an interval from 1 to 4. And so our average value formula is 1 over b minus a times the integral from a to b of f of x dx. Again, that is something you have got to memorize. So I take 1, I do 4 minus 1 underneath it. I do the integral from 1 to 4, and that's all just with our a's and b's. And put my 3x squared minus 2x dx in. And so now I can use the fundamental theorem to solve this. So this becomes 1/3. And I'm going to take the antiderivative here. So I'm going to use a power rule and get x cubed minus x squared, and I'm evaluating from 1 to 4. So I'm going to have 1/3 4 cubed minus 4 squared minus 1 cubed minus 1 squared. And that will become 1/3 times 4 cubed is 64, 4 squared is 16. So I have 64 minus 16. Here, 1 to any power is 1, so I have 1 minus 1, which is 0. So really, this whole part is 0. I'm subtracting 0. And I end up just doing 64 minus 16 and then dividing by 3, which gives me an answer of 16. That's my average value. Again, I want you to keep this in mind when we get to practice free response problems, because they will be used more in word problem and application situations where units are important, and the math is the same. It's just what I've described to you. But you'll need to know how to use it in a word problem. But again, today we're practicing the math, and this concludes this lesson.